All right, ladies and gentlemen, let's adhere our notes to our notebook. Today we're going to be working with the paired t-interval for means. Before spring break, we looked at confidence intervals, the idea of making an estimate based on data. With paired t-intervals, we're going to be working with that same process that we've seen before, which again goes back to those 4 steps. Remember that step 1 deals with the name of our interval, and the name is dependent upon the type of data we're working with. Here we're going to be working with quantitative data that is paired. So our interval is called a paired t-interval, and we're going to be estimating the true mean difference between our pairs. Our degrees of freedom is n-1. So for example, if we have 11 pairs of data, degrees of freedom is 10. Step number 2, we need to check our conditions. These conditions you've seen before. We're going to be working with good quality data. We need to check for normality. And in this situation, we need to check that we are working with paired data. Remember, with our good quality data, that means we're working with randomization. Either that is a random sample or we have a random order of treatments. With quantitative data, we need to check with normality. And remember, with normality, one of the following must be met. Either the population is stated normal, or we have a large enough sample size that the central limit theorem applies, or, and most often the case in this situation, we actually have to graph the data to see if normality is reasonable. We also need to make sure that we are working with paired data rather than independent data. We need to make sure that our data is related in some way. If it's independent, we're going to be using our 2-sample procedures, not a paired procedure. Step 3 is our math. And remember, with a confidence interval, the general form is our point estimate plus or minus our margin of error. More specifically, we're going to be looking at our average plus or minus our margin of error. But our average and standard deviation here are going to be the mean and standard deviation of the differences between the pairs of points. So rather than the actual data, we're going to be looking at the differences between the pairs and using that as our data. In general, we're going to be using our calculator to do the math. We're going to go to Stat, over to Tests, and this is just a 1-sample t-interval. Generally, you will need to put your data in your list first before using that t-interval. Step 4 stays the same no matter what interval we are working with. Based on our sample, we are blank % confident that the true mean difference in whatever lies between those 2 values. Highly recommend that you use the wording from the problem to help you write your conclusion. That will make sure that you don't leave out any words or change the meaning. Sometimes with these intervals, you'll end up with negative numbers, sometimes with positive numbers. So like before, if 0 is included, that means that there is not evidence of a statistically significant difference in the 2 variables. If the entire interval is negative, that indicates there is a difference and group 1 is lower than group 2. If the entire interval is positive, also indicates there is a difference and that group 1 is higher than group 2. So let's look at our example. We just watched a video called Who's Cheaper? And it's comparing the grocery prices at Walmart and Super Target. We want to know if there is really a difference in the prices, and we're going to use a 95% confidence interval to help us out. So we went to the store. We have 9 different items, picked them up at Walmart and at Target and recorded the prices. Problem is, we're not actually interested in those values. We're actually interested in how the prices differ. So we need to subtract the prices to see how much they differ by. For example, with milk, at Walmart it's $3.42, at Target it's $3.49. So that's 7 cents cheaper at Walmart. So Walmart minus Target, we end up with negative 0.07 for the milk, etc. Notice that a negative indicates Walmart is cheaper, a positive indicates Target is cheaper, and 0 would indicate they are the same price. As you work through the problem, make sure you pause the video, try the step on your own, and then unpause the video to see how well you did. So with our data, we're actually focused on the difference in those prices. That's going to become the data we're interested in. We're going to ignore the original two lists of information. So here we are working with quantitative data. We're looking at prices. And we're looking at pairs of data because we have 2 data points for milk and 2 data points for bread, etc. So this is a paired t interval, and we're going to estimate the true mean difference in the price for Walmart and Target. Since we had 9 grocery items, our degrees of freedom is 8. Our conditions. We need to check for randomization, normality, and paired data. With randomization, it didn't tell us in the video, so that is unknown and we need to proceed with caution. For normality, remember one of those 3 things must be met. Either it's stated in the problem, our sample size is large enough, or we graph our data. In this situation, it was not stated. Our sample size is only 9, and so we're going to have to graph our data. Remember to enter your data into L1, and again, we're looking at that Walmart minus Target column in our to enter into our lists. There are lots of different graphs that we could do. We could do a box plot, a histogram, a stem plot, a dot plot, but most of the time we use a normality plot. So second y equals is our graphs on our calculator. Make sure plot 1 is turned on, and for the type, it's the very last one, so scroll all the way to the right. Our data is in L1. Don't forget to zoom 9 to graph. And we end up with a normality plot. Recall that for a normality plot, we are looking to see if our data is linear. Since this graph is pretty linear, normality is reasonable. This data was paired data because we were looking at pairs of prices for each item. Step 3, we need to do our math. Again, we're going to be focusing on that Walmart minus Target column. And so with our equation, we could actually do the 1var stats of L1. But we're going to use our calculator and let our calculator do the math. So we're going to go to Stat, over to Tests, and scroll down to number 8, the t interval. Here we do have data, and my data happens to be in L1. I'm doing a 95% confidence interval, and remember that I need to write down what I type in. In this case, my L1 is the Walmart minus Target data, and I'm looking at a confidence level of 95. When I go to calculate, my interval is negative 0.5751 and positive 0.20844. Since I had 9 data points, my degrees of freedom is 8. Step number 4, our conclusion. We're going to again follow our fill in the blank statement. Based on our sample, we are 95% confident that the true mean difference in the price of products from Walmart versus Target is between negative 0.5751 and positive 0.20844. In other words, Walmart could be anywhere from 58 cents cheaper to 21 cents more expensive on average. That means the interval goes from negative to positive and 0 is included. Since 0 is included in the interval, that means there is no evidence that Walmart has cheaper prices on average than Target. The 2 stores do not have a statistically significant difference that we are able to find.